Good morning. Happy Wednesday. Thank you for making it to school today in the snow and the rain on a tough day to get here. We appreciate the effort, and it's going to help you as we continue to work on day 3, trying to solve these equations that have a bunch of fractions in them, and definitely some of the toughest equations we're going to be solving this year, so that's why it's the 3rd day we're going to continue to practice this. I think 2 big key terms we should be familiar with now. The first, reciprocal. That just means a fraction turned upside down. Reciprocals become important to us because whenever we multiply reciprocals together, it always equals 1. It's basically a way to cancel out fractions or to inverse operation and get rid of a fraction. A least common multiple, that's if we have 2 numbers and we ask what is their least common multiple, we're asking what is the smallest number that they both divide evenly into. This is going to help us both when we're trying to add fractions that don't have the same denominator, and also it's going to be a second method we could use to solve equations that involve fractions, where if we can find the least common multiple for all the denominators, and then we multiply by that least common that least common multiple, that's going to help us eliminate all of the fractions that are in our equation. We're going to show you an example of that later. For your first guided problem today, we encourage you to pause this video, work with your partner, your neighbor, on thinking through how do you explain your method for solving equations when the variable is multiplied with a fraction. So we see 3 examples here where a variable, like m, is multiplied with a fraction 1/2. What is your method for solving equations like that? After you write an explanation, it'll be a lot easier to discuss this with your partner first and then write about what you discussed. Then you're going to go ahead and you're going to solve each one of these equations, insert an image of your work. So go ahead, pause the video, take care of that. Welcome back. So I'm going to go ahead and first talk about my explanation. My method, whenever I see a fraction that's multiplied with my variable, and I'm trying to solve this equation, trying to get down just to m equals a number, I think again about inverse operations. What's the inverse of multiplying by a fraction? And I think it's as simple as saying the inverse of multiplying by a fraction is to multiply by the reciprocal. So whenever I want to get rid of a fraction that's a coefficient, I multiply by the reciprocal to eliminate a coefficient that is a fraction. What does that mean? If I see a fraction times with my variable, that's a coefficient, that's a fraction, I'm going to just multiply by the reciprocal every time because that's the opposite. And a reciprocal times together always makes 1, and that's what I want to get down to is 1m or 1n. Let's look at some of the examples. 1/2 m equals -6. The reciprocal of 1/2 is 2/1. So if I multiply 1/2 by 2/1, they'll cancel each other out. More in depth, it would really make 2/2. 2 times 1 is 2, 1 times 2 is 2, and anything divided by itself really just gives us 1. So that would get me down to 1m, but anything I do to one side of the equation, I'm required to do the same thing to the other side of the equation. So every term over here, the -6, also has to get multiplied by 2/1. -6 times 2 gives us -12. So our final answer, m equals -12. And the way I got there, at least, is to multiply both sides of my equation by 2/1. If you were struggling a bit, hopefully you're thinking now, how can I get rid of -3/4? A fraction is a coefficient that's times with n. The inverse, or the opposite of multiplying by -3/4, is to multiply by -4/3. A negative times a negative would give us a positive. 4 times 3 would be 12. 3 times 4 would be 12. And we know that any number, just erase there, divided by itself would really just give us 1. So that gets us down to 1n. But again, both sides need to be multiplied by that -4/3. 12 times 4 is 48. 48 divided by 3 gives us 16. But I think it's easier to just think 12 divided by 3 is 4. So I could say 12 divided by 3 would give us 4/1, same fraction, and 4 times 4 gives us positive 16. I'm going to pause for a second and talk about what just happened there again. We had a negative times a negative, So we had to multiply both sides by negative 4 over 3. So that gives us a positive. 12 divided by 3 gave us 4, and 4 times 4 is 16. Alternatively, go ahead and figure out yourself. If you did 12 times 4, that would be 48. 48 divided by 3 would also give you 16. Two different methods to think about multiplying a fraction with a whole number. At this point, if you did not get the third equation with p in it, negative 5 over 2 times p equals 15, you should understand how to do a problem like this. So again, if you struggled with this, please pause the video for a second. Talk with your neighbor, try to work this out on your own before I show you the simple step we're going to use. If I'm timesing by a fraction or multiplying p with a fraction, the inverse is to multiply by the reciprocal of that fraction. Those would cancel out. The only thing that would be left is p. But again, any operation performed to change one side or the left expression has to also be done to the right expression. So I multiply this side by negative 2 over 5. 15 times 2 is negative 30, so I get negative 30 divided by 5, and negative 30 divided by 5 gives us negative 6 for an answer. Alternatively, 15 divided by 5 would have given us 3 over 1. 3 times negative 2 gives us the same negative 6 answer there. So now at this point, you're going to be pausing the video. You're going to be taking a look with your partner on the second half of the guided problems today. Here, you're going to be asked to explain your method for solving equations when you need to combine like terms and the fractions have a different denominator. So here we see we're going to have to combine these x's, but 3/4 x, it's a different denominator for this fraction than 1/2 x. So what is your method for solving these equations when we see that? There's actually two methods. If we come back, objective 3 shows you a second method I think is a little easier here, a little more complex, but a little easier if you understand how to use it. We're going to show you both methods. So again, pause the video, work through part 2 by explaining your method, and then trying to solve both of these equations with your partner. As you're doing that, I'm going to quickly write the equation for the first one. 3/4 x minus 1/2 x equals 5. Again, your video hopefully is paused. Now you're coming back. My method, what I'd write for my explanation, option 1, convert fractions to have the same denominator. We're going to talk about that method on the whiteboard in a second. Option 2, which I'm going to show you as well on a whiteboard, I think is a better method here. Multiply by the LCM, which is the least common multiple, to eliminate fractions. So we're going to show both of these methods here for the first one, and then on your own, actually, you're going to work out the second equation with your partner. First method, I want to combine these fractions. I see they're both variable terms. They are gathered on the left side of the equation, so I'm allowed to combine these like terms. But I cannot combine these like terms until the fractions have the same denominator. This one, hopefully you can see 1 over 2. If I want to convert 1 over 2 to an equivalent fraction, I say, what number do I multiply 2 by to get the denominator to be 4? I would have to times that by 2. And if I times the top and the bottom, the numerator and the denominator of a fraction by the same number, 2 divided by 2 would just be like multiplying this fraction by 1. It wouldn't change the value, even though it's going to change the numbers. That helps me realize 2 over 4 is an equivalent fraction to 1 over 2, but now it has the benefit of the same denominator. So I'm going to switch 1 over 2 to the fraction 2 over 4. At that point, 3 over 4x minus 2 over 4x just gives us 1 over 4x, which is equal to 5. And from the first set today, you should understand the last step. The inverse of multiplying by 1 over 4 is to multiply by 4 over 1. That reciprocal can help us eliminate the fraction. 5 times 4 leaves us with 20, which is equal to x. That would be method 1. That works perfect. It just takes a little time up front to figure out how do I get all the fractions converted to have common denominators so that they can start to be combined. Method 2